It's time to get ready for our test. So, quick logistics. You guys know that tomorrow is the test on Chapter 10A. 10.1, 10.2, 10.3, 10.4, 12.3, a.k.a. the handout. Does that make sense? A.k.a. the handout. So our 10.5 is completely not on the test. The test tomorrow, a lot of you guys were asking about calculators. I am going to allow you to use the calculator. I showed you all how to find the conic section thingamabobs so you could access the general formulas to the conic sections, right? If you wanted to, you could theoretically access them if you have your calculator. I don't want anyone to be like odd man out. Oh, I didn't know it was there. And then it's not fair because other people are cheating and using it. Not literally cheating, but using it. But there will be questions that are worded such that you can't do the whole test in that one little baby to show you the standard form of ellipse and hyperbola. And it also shows you the standard form. What if you're given the beginning form where you need to complete the square and move things to one side and divide by a number and all those things. So, and on the test itself, I could have blanks like with the probability section. I could have blanks that you need to fill in for full credit that your calculator could not give you. Does that make sense? So all I have to say, you can use your calculators. Great, don't study. Don't make that conclusion. That would be a really bad conclusion to make, okay? Okay. So what are we going to do for the test tomorrow? Study and finish the review. To that end, let's go ahead and go over questions on this homework. There are two evens, number 4 and number 10. It's not in the back of your book. It's not even in my PDF because it's a different book. So I need you guys to go ahead and give me what number 4 was, and let's check it all together. Number 4 gave you what function? Equals what? Which you guys were hopefully able to get to be x squared over 4 plus y squared over 16 equals 1. And hopefully you were able to see that that is a very classic ellipse. True? Okay. You were supposed to graph that ellipse. I know there's rotation happening, but remember, can you rotate before you get the base figure, the two-dimensional figure? No. Did I tell you anything about the test as far as if there are problems, when there are, I shouldn't say if, when there are problems that you need to rotate? What did I tell you? You have to put the rotation arrow, that's worth points. Shows me the axis you're going around according to what the problem says. But didn't I also say I will give you the base figure for those? I'm not going to make you have to do conic section, graphing, and rotation. So I'll give you the parabola or the ellipse or the hyperbola. I'll give that to you. It's drawn in the graph. You just have to spin it. Showing me the right axis, the correct axis according to the question. Show me either an artistic or non-artistic rendition that shows me exactly which one it is as far as which type of quadric surface, solid revolution it is. And then be able to attach the name. But I will not make you make a conic and rotate. That would be too much time. Does that make sense? Okay. So in this one, horizontally oriented or vertically oriented? So maybe I should draw this a little bit differently, right? Why is it vertically oriented? What do you notice? This is good review from chapter 10 anyway. Because the A is where? Under the Y. Good. So my major axis, is going to be what length? No. The major radius is 4. What's the major axis length? 8. Good. So it's going to go up 4. That's going to go down 4, right? The entire major axis, if that clue shows up on the test, is 8. The radius is 4. Why am I going up 4 and down 4 from the center? What's so special about the center? How did I know it was 0, 0? Good, good. If there was, I'd have to do some completing the squares. Would have been even harder. What is my minor axis length? 4, because the radius, the minor radius is 2. Does that make sense? Of course. Wow. Okay, so we have our ellipse. What went further? Why are you square rooting? We square rooted the 4 and the 16. Is that what you mean? We don't need the foci for revolving. Do we need the foci for like review problems and going back to section 10.3 10.3, is that ellipses, right? 10.3. Hyperbola is 10.4, 10.2 parabolas, 10.1 lines and inclinations. Plus. Oh, if you were finding foci, it would be a squared minus b squared, which would be inside, but we don't need the foci at all for these types of problems. But Colby was trying to review foci. Okay, I get to revolve him, but how? What's the problem say? About the y-axis. So, what type of ellipsoid, pause, look at your homework, did you put a rotation arrow around the y-axis? If not, colored pen, correct it, because that would be a point off. At least a point. Did you draw the rotation arrow around the y-axis? On the test, I will give you points for putting it on the right axis. Pause. On the test, I wouldn't say y-axis, I would say major axis, but either way. Do you know? For ellipses, the A is always the biggest, indicating the major. Does that make sense? But whether you call it A or B, I don't think will make a big difference for tomorrow. It's more realizing that the bigger of the two for ellipses is always the major axis. That's the most important idea. What type of ellipsoid, right, just ellipse with an oid at the end, ellipsoid, what type of ellipsoid will this form? Prolate. Good, like a football? Or if you don't like a football, like a pill? If you don't like a pill, like a something else. So prolate. It's a prolate ellipsoid. And how should you have drawn it? Basically, my non-artistic ones, yay, it spins. Yay, it spins, right? However, my more artistic ones maybe would have had a little more fun with perspective, etc. You could have maybe done some fun spinning things. But I want you, remember, I want you for the ellipsoids to be very careful about how you graph it. And any rotation that you show needs to be parallel to the rotation arrow. What do I mean? What if this ellipse had been the other one? What's the other one? Oblate. Oblate, if you want to think obtuse. If it had been oblate, how would you have drawn it? Yeah, do like an atom or something and be like, yay, spin. Actually, not too bad. Right? Is this, if it had been rotated about the minor axis, if it had been rotated about the minor axis, is this, does this, for me, teaching, grading, your tests, after you finish them tomorrow, should these look very, 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 very different? Good. They should look very, 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 very. That was not a homework problem, though. Let's get rid of that. That one we decided not to do, although you did a homework problem on it. I'm sure we'll go over it. Number 10. Wait. Is number 10 the one I did on the board on Friday? Yeah. With the inscribed theme blah, 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 blah? Oh. Okay, never mind. Oh, but did we do that one? Or we did one like it?
We did one like it.
Okay. What was the equation for number 10? And it says from, can I write it in interval notation and we're good? So, 1/2 x, how'd you guys graph it? mx plus b, what's your b? 0, because it's plus nothing. So, I know it's going to be going 0. I know it's going to be going what? Up 1, because my slope. Over 2, up 1, over 2. How long do we keep going for? Oh, just right there. Stop them. Remember, that's just telling us where to stop. What do you guys think? Approximately? Okay, where's he spinning? The x-axis? Grade your homework. Did you put a rotation arrow around the horizontal? Follow. Now careful. Follow the spin. I need, right? Ta-da! Follow the spin. Right? Roughly. And put some perspective on there if you want. And then dun 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 dun, roughly dun dun. There we go. There you go. Question. If you showed it here, would you be right? Nope. That'd be going around the y-axis. Okay. Any questions on odds from the handout that you were able to check in the back? Number 13. Okay. I'm going to go ahead and pull up the handout real fast. I think I have it right here, just so we can peek at number 13. We'll see the three-dimensional inscribed D1? Yeah. Okay, number 13. The x squared plus y squared equals 25. You guys see that this should be a circle. Oh, it's up here. Sorry, wrong picture. It's this guy. There we go. We have the circle, x squared plus y squared is 25, so we have a radius of 5 all the way around. It's rotated about the y-axis to form a sphere. They didn't really show the sphere rotation, but that's okay. They showed the cylinder that's inside the sphere. A cylinder is inscribed with its axis along the y-axis. Find an equation of the volume of the sphere? No, the cylinder, right? The volume of the cylinder. You guys can keep reading. It's on the next slide. Did anybody find the volume of a cylinder formula? We have to start there. Area of the base, which is a circle. What's the area of a circle? Oh, that's circumference. Pi r squared. Area of the base times the height. Okay, so volume of a cylinder. I need this volume, like number 11 was the one that I did on the board, right? Okay, I need the volume formula to have x's and y's. So we got to look at this representative point. Don't go guessing a decimal of this one. Remember, the cylinder could be like really wide and short, or it could be really tall and narrow. This is just a representative cylinder. So I want you guys to look at the shape itself and be like, if the radius goes from here to here, r is going to equal what? And if the height goes from here to here, h is going to equal what? To get to a point, don't we go over x and up y? So relate those two. What's x going to be the measurement for? R. Oh. What's y going to be the 2y. Nice. So I can come over here and say, well, v is equal to pi x squared times 2y. Or v is equal to 2 pi x squared. So the 2 wasn't because of the geometric formula. The 2 was because we needed 2 of these y lengths to make the entire height, because it went up and down from the x-axis. What's missing in my bottom one? The y. I have the 2, I have the pi, I have the x squared. Why is the y missing? Because the y needs to be in terms of x's also. And how can I get y's in terms of x's? Go look at the equation with y's and x's. And ask yourself, how do I get y by itself? Well, let's subtract the x squared and plus or minus square root. If you guys notice, this y, if you go up y, down y, you don't have to do the plus or minus. It'll hit at both. We only need one. You don't need to find both y's, because whatever the positive one is, the negative one will be also. So we can just take this positive square root and plug it in. And you're trying to find an equation for the volume, sorry, coming back up. In terms of x, y is what we just did right here, 2 pi x squared times the square root of 25 minus x squared. Plot the volume of the cylinder as a function of x. Look, all x's. And sketch the result. Find the max volume, the x value of the max volume and that volume. So, let's see. Is that about where it was? Okay. Graphing calculator's out just in case you're not quite sure what they're talking about. What they're saying as making it a function of x. what they're saying as far as making it a function of x. They're saying take this volume formula. Sorry, the calculator's in my way. And make this equal to y1 in your calculator. Take this volume formula and make it equal to, hi calculator, I see you. It's like my dog. Anyway, so give it attention and it'll go away. Don't worry, I love my dog more than that. Just sounded bad. Nothing, huh? Come on. There we go. I'm stealing this real fast. So you guys would have made this function y1. I'm putting it in your notes just in case someone wasn't ready to totally go over it right now, but you might want to access it later. Here it is. Okay, so you're taking this guy, you would have made him this function right up here. What are we missing? We're missing r equals x, and I think nothing else really got cut off too badly. Okay, so in our graphing calculator, you would have wanted to throw in this function into your y equals. I'm going to do zoom standard real fast. I'm going to go back and change my function to be what I see here. Because I know that some of you guys just saw the board for number 11, but you might not have known exactly what you were supposed to do. And I don't think I finished that one in the graphing calculator. So you would have plugged your 2 pi x squared times the square root of 25 minus x squared. Would have graphed this little puppy. You are looking, is there a place where there's a max? Wait a minute, I see a min. But doesn't the question technically say max? Guess what that means? There must be more going on up there that I don't see. So I'm going to go ahead and zoom out just a little bit in the sense of seeing higher on my graph, changing the y max. I'm just going to go with something crazy like 50. Let's see if we can see a little more. Huh. There's still nothing, so this is ridiculous. There is no max, right? Those of you guys that zoomed out, how much did you have to zoom out to see it? Ooh, looky, looky, I have a max. I think I do. I'm going to go up to 400, which will probably be overkill, but that's okay. I should see it now. There he is. Dun, 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 dun. Mr. Max. Now, hold on. Which max do we want to find? The one on the left or the one on the right? Yeah, because if you think about it, isn't x supposed to go along with the radius, right? So let's choose a positive number for the radius, not a negative. Negative radius is kind of awkward. I mean, it is x to the right and to the left, but we're choosing the positive number. That's a good thing to think about. But you guys know left bound, go to the left of the max, right bound, go somewhere to the right of the max. Max is somewhere in between. So what's the final answer? There's a maximum volume. Hey, this is like the worksheet I handed out to you guys about the max of, at, or we could say when. The maximum value of the volume. Remember, we made y1 the volume, so this, we actually have to think about this being v, because we made y1 equal to the volume. So it's a maximum volume of 302.299. 300. You guys agree with what you found? And that's going to be at or when x equals 4.082. And I think the question asked for the x first and then the volume. Dun, 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 dun. Is it going to be one of these? Like 11 or 13 on the test tomorrow? Yes. It might not be normal credit.
Thank goodness.
Okay. Questions on the review? No, questions on any other odds besides 13. Questions on the review? Oh, sorry, David. Okay, let me clear this off real quick. So looking at number 3, which was the graph of number 4, but oh, that would be the atom one where you can just connect it. It'd be the oblate.
But like the back of the worksheet makes it like look different.
Oh, let me check it out. What's it look like? Let me see if I have it up here so we can all look together. have it? Oh, I don't have it. Sad day. Okay. Who has the worksheet? Oh, thank you, thank you. Ah, that's great. I wish I could. I can show it. For number 3, David's asking about how they showed it, and this is a reason why I've made such a big deal about everything. For number 3, he noticed that it was supposed to be oblate, the exact same problem that we did. Let me show you how the book showed it. And this is why I have to have some of you artistic ones be super, super careful with how you show this rotation. If you were rotating this way, some of you would think, oh, I can just go ahead and show this, and it's going to be a pill too. It's going to be a prolate too. And here's the dilemma. If you're actually looking at it spot on, the fan would look like this. The oblate one would look like this. This one that we show at an obvious distance. Oh, that's rough, but okay, we'll pretend. The one that we show like this, the reason that we can see it like this is because I have it tilted. Does that make sense? I have it tilted to where we can see the fan going this way. But guys, if there's a fan, and if you're looking at it straight on, aren't you just going to see like this portion of it? Does that kind of make sense? So, but the problem is in my head, I look at that and I think it's prolate. So what I've shown you guys is technically this would be oblate. I don't want you showing me this tomorrow at all for anything. Because that is obviously oblate. And this one is, because of the rotation, obviously prolate. So don't use that illustration on anything tomorrow. And my artistic ones, I see what you're thinking, that if you think it's prolate or if you think it's oblate. But please, 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 prolate versus oblate. This one is about, that's an awkward way of spinning. I never spin it that way. Lo siento. That was weird. There we go. I think that's because I'm right-handed though. Anyway, this one will always be the prolate, and a prolate is always when you're revolving about which axis? The major. And then this one would be going around the minor, which would be an oblate. Okay? Thank you for bringing that up, David. That's exactly why I've been so precise with how I want you to do it. Thank you, thank you, thank you. Okay, review. You might have absolutely no questions whatsoever, and the review, guys, does not have you practice the 3-dimensional, which is, well, that's why kind of this homework is nice to have last, because it's the one that you just practiced. We went over questions on, etc. But let's see if I can find it. Where's the review? Do I have it? Oh, I don't have the review. Lo siento. That's okay, I can make it. Boop, boop. What is this? The chapter 10A review. All right, let me go ahead and open it up because some of you guys, frankly, might not have started it, slackers. But for the rest of you guys that did start it, any questions that we have on the review? 17. Same, 17. Anything else besides 17? Okay, for those of you guys that have not written it down yet, let me go ahead and freeze the screen so that you guys can be writing down the test review. You guys see it right here, right? Test review, chapter 10A. Okay, I have my little cursor on it, so if you need to write it down, there it is. Meanwhile, let me go grab the book and open it to number 17. If you're not ready for the review, remember, you can always put this in your workspace, right? Another nice use of your workspace. You can put the problem in the workspace and have it ready whenever you get to number 17, which hopefully is not at 2 a.m. this morning. Tonight? Tomorrow morning. Anyway. Ooh, it's the tangent line. Great question, guys. All right, I don't know where you guys are, whether you're still writing down the review or whether you're ready for the questions. So let me get both up on the screen so that we can look at them. Ooh. Oh, that's weird. Oh, it's right here. It blended in with my keyboard. Okay. Hey guys, what's number 17 on? Something that a lot of you have not thought about for quite a while. Tangent line to a parabola. Probably, I would say, as far as difficulty, the most complex idea of the chapter. Unless you really hate drawing things, but okay. Find the tangent line at a point. Let's remind ourselves of what's going on. Can we get a graph of this parabola? Yes or no? In this entire chapter, is it generally good to try to visualize? Generally, for most of you. With the foci and the vertices. Wait, vertices, that's just the major axis, or it's the hyperbola, or it's the parabola. Anyway, so in this one, I know that I have the point 0, 0. If I can actually put a point. Okay, I have the point 0, 0. Now it's even worse. What now? Of course, now it's on. Okay, I have the point 0, 0. I have the point, let's see, when x is 1, that would be 2-ish, right? When x is 2, that would be 8-ish? Yeah. Ooh, way up here somewhere. 1, 2, 3, 4, 5, 6, 7, 8. Okay. But the nice thing is, all I really need is -1, right? -1, 2. And I could do -2 and it'd be back up here. Okay, so somehow I have this parabola. We can keep on going. They're wanting me to find the equation of a tangent line that hits at the point -1, 2. So with that, we have to remember some of our characteristics of parabolas. And a characteristic of the parabola is, if we could find the focus, there's only one of a parabola, and the directrix, I think that distance is going to be kind of important, right? And to be honest, we don't even actually need the directrix. All that we really, really need, even though the length will be the same, is the focus. How do we rearrange a parabola in order to find the P from which or with which we can find the focus and the directrix? How's that formula? Go. Yeah, we want it to look, well, wait, the x is squared, right? So I need to make it match. X squared is equal to 4p times y. And technically x minus 0 squared and y minus 0, but I don't need to put that because there's no addition or subtraction going on. But wait a minute, how do I rearrange this guy to look like that guy? I need to get x squared alone, so divide by 2. Mine is 1/2 y. So what does that mean that p needs to equal? 1/2 equals 4p. 1/2 equals 4p. Divide by 4. Isn't p 1/8? Double check my math, but 4p has to equal 1/2. P has to equal 1/8. 1/8 means, where's my focus? We'll call him F. Not very far off the center. He's not very far off the center. But I can say that my focus is the point. The x stayed the same and the y added 1/8 to the vertex, right? So I have my focus, 0, 1/8. I have my point, -1, 2. Do you remember how the tangent line works? The tangent line will skim, and the distance, d, between the focus and the point, measured down from the focus, will get us our new point from which, or point on which, the tangent line intersects the axis of symmetry. Patricia? Oh, I didn't. I reminded us of what the standard form is that we need to have, which is with the squared term, and I saw the x was squared. So I realized x squared will equal 4p times y, or x minus h squared. Maybe it'd be easier if I didn't make it so specific to the problem. I always remind myself of the standard forms and then try to make it match. Does that make sense? So I saw that because the x is squared, this is the standard form I wanted to look at. And so I saw the x squared had to get by itself, which I could do by dividing by 2. And so x squared is equal to, divide by 2, 1/2 y. So therefore my hk is 0, 0. And then this coefficient had to line up with 4p. Then I just divided, I set the 2 equal to each other. 4p has to be 1/2 divided by 4, 1/8. So the relationship between the point and the focus and the point on the tangent line is that the distances between those two are exactly the same. And I can always find the equation of any line as long as I have 2 points. This is the point that I need. This is the point that I really, 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 really want, and it's unknown until I find it. So I can go ahead and find the distance. We already found the focus. By just taking the strict distance between 2 points. So I have x2 minus x1, so 0 minus -1, right? Squared, plus y2 minus y1, so 1/8 minus 2. Without going too in depth into all this, it'd be 1 plus 15/8 squared, which would be pretty nasty. Right? So it's 16/8 cut in half. So then I have 64. I wish I still had my calculator. 15 squared is 225 over 64. 225 plus, I can make this one into 64 over 64. I would end up with the square root of 225 plus 64 is 289. Hey, that's a perfect square. That's really, really nice. Because the square root of 289 is 17, right? So I'm actually going to end up with the distance being 17 over 8. And from that, I can find my point to be 1/8 minus 17/8 with the exact same x value of 0. Starting at 1/8 and taking away the 17/8, we're going to have the point 0, and negative 16/8 is -2. So now all I need is to make an equation of my tangent line. And to make the equation of the tangent line, I can do y minus y1 equals m times x minus x1. I'm going to use this one. Yeah, because he's a little bit prettier of a number. I guess they both are good, huh? I could do x minus 0 and then y plus 2. And to find the slope, I would do y2 minus y1 all over x2 minus x1, which will end up being -4. You guys could rearrange it. But there's the equation of the tangent line. It is from the chapter, and it is review. So I'm glad we were able to do it all together today, yeah? So those who started the review, good job, because you just saved your class from not having reviewed the tangent line problem, which once again I think is the hardest. Kiddos,